Welcome to Train Signal. This is the Using Direct Access and VPN Connections lesson in the Windows 7 Administration Training course. In this lesson, we'll start by talking about a new feature in Windows 7 called Direct Access, and we'll talk about why it's a cool new feature in Windows 7. We'll then go over the Direct Access Server requirements portion of the equation, but we're not going to be actually covering the Direct Access Server implementation, as that's well beyond the scope of this client-focused course. Next, we'll talk about how to configure Direct Access on the client side, and we'll move ahead from there to talk about the understanding of Direct Access connection types, and then actual Direct Access client requirements. Once we're through with Direct Access, we'll move on to more traditional remote access methods in the form of VPNs. Once we start with some basics on enabling VPN-based remote access, we'll talk about some VPN authentication mechanisms, including some password-based authentication mechanisms you should understand. Then we'll wrap up with a short demonstration of how to create a Windows 7 VPN connection. GlobalMantics is a company on the move. The company has an ever-growing force of salespeople making the rounds, visiting customers, going all over the country, selling the GlobalMantics wares to people to increase the bottom line. The goal is to make sure that these sales professionals can keep the wheels of business turning and have the most current information at their fingertips by staying in direct contact with the mothership. Windows 7's Direct Access and VPN capabilities are a very good fit for these needs. From a business need perspective, mobility has become the norm. This is a very high priority these days in many organizations to keep mobile professionals in touch as if they were in the office. It's important to enable this mobility in such a way that the organization is not left at a security risk as a result, however. As I mentioned, Direct Access is a brand new Windows Server 2008 R2 and Windows 7 feature. Direct Access enables an always-on VPN-like connection, but it's without the need to establish a traditional VPN connection. If you've used VPN connections in the past, you'll remember having to log in with a username and password and all that good stuff. Direct Access negates the need for user intervention when it comes to establishing remote access. It's also fully bidirectional, so corporate servers can actually see the clients that are connecting to the Direct Access infrastructure. This means that Direct Access can be integrated with network access protection, as well as group policy and software update mechanisms that are in place in the organization. GlobalMantics does use group policy and software updates, so the use of Direct Access is a boon for the company. As I mentioned, Direct Access requires no user intervention. In fact, it can connect even before the user logs into the machine. With traditional VPN clients, you have to wait until you're logged in order for to establish the connection in most cases. Direct Access connects before the user logs in, at which point the client can see DNS servers and domain controllers, and then after the user logs in, they can see the other services to which they have access. So this makes it fully transparent to the end user since the connection process is automatic. And it's connected as soon as the computer can see a network connection. So it makes it a really nice way for users to have this very transparent. Basically, they're taking their desktop machine as if it were on the intranet and taking it out into the world. Direct Access makes it very nice for the user, but it does require some significant server-side infrastructure in order to operate. Establishing the server-side configuration is beyond the scope of this course, but I want to go over what the server requirements are so that you gain an understanding of what it takes to get a Direct Access server implementation up and running. First of all, the Direct Access server has to be a domain-joined Windows Server 2008 R2 server with at least 2 network adapters. The public network adapter has to have 2 consecutive public IP addresses, and the other adapter in the machine must be connected directly to the internal corporate network. In addition, you have to have a public key infrastructure in place in some way, shape, or form. During the Direct Access configuration and implementation process, the wizard will create an Active Directory security group to which you'll add the computer accounts for the computers that are going to connect via Direct Access. It's this security group that allows the Direct Access clients that initial connection before the user actually logs into the machine. From an Active Directory domain perspective, you have to have at least one Windows Server 2008 R2 domain controller and DNS server deployed on the network in order for DirectAccess to operate. And further, any resources that are going to be accessed on the internal network must be IPv6 capable, and any software that's going to be used on the client side has to be IPv6 aware. So if you have some software that only works with IPv4, it probably won't work with DirectAccess, even if you use IPv4 traversal means to gain access to a DirectAccess environment. All of DirectAccess stuff, once it's up and running, relies on IPv6. There are basically 4 different access types that are available for DirectAccess. The first one is a public IPv6 access or connection type. This is the eventual goal. The world's gone IPv6, every machine has an IPv6 address, and the internet doesn't use IPv4 anymore. In this case, the client is going to use a public IPv6 address, and they're going to connect to the GlobalMantics network directly via IPv6. This is the perfect world scenario. And it's not really all that achievable yet because most organizations have not even begun to make the move to IPv6. Now, in other cases, there's clients that use a public IPv4 address. These clients might be sitting in a coffee shop that has a public address or something along those lines, or they may be connected at home directly to a cable modem from which they're getting a public IPv4 address as opposed to a private IPv4 address. In these cases, DirectAccess uses a mechanism called 6-to-4, which establishes an IPv6 to IPv4 tunnel between the client and the DirectAccess server. The vast majority of home-based and coffee shop-based clients are going to use what's called the Teredo connection, and these are for clients that sit behind some kind of a network access translation or NAT device. These kind of devices use private IP address spaces. These are the IP addresses that start with things like 192.168, 172.16 through 172.32, and the 10.x.x.x address space. These clients cannot use a 6-to-4 connection because they're not public IP addresses. Instead, these clients are making use of a network address translation that's converting their private IP address into a public IP address. So they use this Teredo mechanism, which is fully supported by DirectAccess. Now, when all else fails and none of the other 3 connection types will work, DirectAccess can fall back to using an HTTPS connection. This does not perform nearly as well as the other connection methods. So if it's at all possible, try to make sure that you're able to use either public IPv6, which is unlikely, 6-to-4, which is somewhat more common but still not hugely common, or the Teredo connection, which is actually going to be the most common type of connection that you'll probably see out in the real world. There are some basic DirectAccess client requirements that you should keep in mind before you undertake a DirectAccess rollout for GlobalMantics. Most notably, only the Enterprise and Ultimate editions of Windows 7 will support the DirectAccess feature. As you can see by the graphic on the left-hand side of the screen, the Starter, Home Basic, Home Premium, and Professional editions of Windows 7 do not support the DirectAccess feature. Next, only domain-joined computers that belong to the DirectAccess security group are able to access DirectAccess servers. So this security group is created at the same time you deploy DirectAccess on the server side. Keep that in mind when you're working with DirectAccess on the client side. And finally, DirectAccess configuration is distributed to clients via group policy, and there's very little manual configuration absolutely necessary. Do understand that these group policies are scoped in such a way that only the machines that are a member of the DirectAccess security group are going to have these policies applied to them. It is possible to configure individual clients with the netsh command if you would like, and we'll be looking at that in just a few minutes. In most cases, you're going to use group policy objects to configure DirectAccess. These primary objects are located at Computer Configuration, Administrative Templates, Network, TCP/IP Settings, IPv6 Transition Technologies. The objects you see on your screen are 4 primary objects used to configure DirectAccess. The first one is the 6-to-4 relay name. The next is IP HTTPS state. Next, Teredo default qualified and Teredo server name. We'll be looking at all 4 of these in just a second. There's also another group policy object that's important to understand, and this is the name resolution policy that's in place in group policy. This is generally configured during the server-side setup, and as its name implies, it helps define what the name resolution policy is going to be for direct access clients. I'm now going to move over to a GlobalMentix desktop, and we're going to look at group policy and how it works with direct access so you can get an understanding for what these policies actually do and how to configure them. As you can see, I've already opened up the group policy editor on GM7075 to the IPv6 Transition Technologies node. And you're going to see here that some of the things we just talked about are actually here and real policies, so I didn't lie. Well, the first one is the 6-to-4 relay name. And this policy setting, as the description indicates, allows you to specify a 6-to-4 relay name for a 6-to-4 host. Now remember, the 6-to-4 connection type is used for clients that have a public IPv4 address, not a private IPv4 address. So when you enable this policy, you'll enable a router name here, but it has to be if you're anticipating clients using public IPv4 addresses. In most cases, you're going to set up a direct access server that allows multiple connection types because you can't be guaranteed that clients are always going to be connecting from a single type of connection. Some will use private and some will use public IP addresses. Some will be able to use IPv6, and some are going to have to fall back to HTTPS. The next item I want to discuss is the IP HTTPS state object. This allows you to provide HTTPS information for connectivity to a remote network. When the policy is enabled, the HTTPS interface is always present, even if the host has other connectivity options. So what this means is you'll always have the option to use HTTPS if you like. If you disable this policy, you're not able to use HTTPS as a connection method. Some organizations will disable the use of HTTPS because it does not perform as well as the other types of direct access functions. So you're able to use HTTPS when this policy is not configured or when the policy is enabled. Next, we have the Teredo default qualified. Remember, the Teredo connection type is used when you have a private IPv4 address behind a NAT router and you're connecting to a direct access host. This allows you to get a Teredo connection into a qualified state. If you enable this policy, you can choose only to have Teredo in an enabled state. So if you choose to enable this policy, then you're going to be making this connection type available to your clients. If you disable this policy, then you're going to use a local host setting, which could mean that Teredo is not available to your clients. Next up, we have Teredo server name. If you're going to allow this type of connection, provide a server name that will be used by the client to connect. Finally, let's talk about the name resolution policy available at Computer Configuration, Windows Settings, Name Resolution Policy. You'll notice that one of the tabs here is DNS Settings for Direct Access. A lot of this stuff will be set up when you do your server-side configuration. However, if you want to make sure that it's set up correctly, make sure that you have DNS Settings for Direct Access enabled on this tab, and you can add DNS servers as you wish. You can actually use different DNS servers for direct access than you normally use for the network if you like. You can also choose whether or not to use IPsec in communication between the DNS client and the server. This is just a more secure way to handle DNS information, but it's all dependent on what you feel is best for your organization. As I mentioned, it is possible to use the netsh command to manually configure an individual client, although as soon as you use group policies, these commands are going to be overwritten by group policy. We've talked about a number of different connection methods, so the commands you see on your screen are different ways that you can configure those different connection methods depending on what kind of connection method you're trying to configure. The first connection method is the Teredo one, and it allows you to specify what you're going to use for a public server IPv4 address for use with remote access. The second command establishes the server IPv4 address, the public one, for the 6 to 4 relay. And the next one allows you to provide an HTTPS address that you're going to use for the HTTPS connection type. And then there's some commands here that allow you to view interface statistics. So I'm going to go back over to a GlobalMantics client right now, and we're going to go ahead and use the netsh command to make some of these configuration changes just so you can see how it works. Here we are at a GlobalMantics desktop, and I've started a command prompt as an administrator. As you can see, I've already typed the command into the command prompt to set the Teredo options for the interface, the IPv6 interface. So this is the interface that's going to be used when a machine is sitting behind a NAT device. And this is how we want to configure the client to connect to the machine, the direct access server, with the public IP address of 100.100.10.10. Now when you hit the enter key, you don't see a whole lot because it just says OK. That's where the net shell interface IPv6 show Teredo command comes in handy, and it actually gives you some information about what you just created. So you're not getting completely lost and getting confused about what you've done. The next command we're interested in is setting the 6 to 4 interface command. This is where you're using a public IP address as opposed to a private IP address. Again, we're going to set the relay information to the same address we used before. This is the public IPv4 address of our direct access server. And when I hit the enter key, I'm going to get the similar OK. And now I have to get some information, so I can use the interface 6 to 4 show relay command, and I can be shown that the relay actually was created. And finally, if you want to add an HTTPS interface to this whole setup so that you can have this fallback in case none of the other connections work, you can use the network shell command to add a full client interface. But you have to use the full domain name and or IP address for the public IP address for your direct access server with the format as follows: https://public IP address /IP HTTPS. And again, you're going to be told that the interface was created. Now, unlike the other commands, if you want to be able to get some information about the HTTPS interface, you may not be able to use the show interfaces like you were doing before. So I'm using network shell HTTP interface, HTTPS tunnel show interfaces. And you're going to see that not much shows up there. Instead, if you do a dump command, you'll get a full configuration script that actually does show you all of the information that you created as it pertains to an HTTPS tunnel. So even if the show interface doesn't work, you can use the dump command to get some information about what's configured on this system with regard to the HTTPS interface. Now, we just got done talking about direct access, which is a brand new transparent connection method available only in Windows 7 and in Windows Server 2008 R2. Not everyone is going to be able to enjoy the luxury of pushing out Windows 7 in conjunction with Windows Server 2008 R2, nor will everyone want to be able to use direct access. So there's other connection types that you want to understand, namely VPNs. VPNs are a traditional, broadly supported remote access and point-to-point connection mechanism. VPNs allow individual computers to connect to networks, particularly corporate networks, and act to a point as if they were a member of that network. Point-to-point VPNs can help to establish connectivity, permanent connectivity, between two separate sites. So you might have 10 computers at the Utica site for GlobalMantics and 10 computers at headquarters. If you install a site-to-site VPN between the two, they act as a single network. Now, for the purposes of this lesson, we're focused on the remote access side of the VPN house, not the site-to-site side. Windows 7 supports 4 different VPN connections that we're going to talk about in this lesson. The first one is the Internet Key Exchange version 2, or IKEv2, that also includes what's called VPN Reconnect, which is a new feature that's pretty cool, and we'll talk about it. Next, you have the Secure Socket Tunneling Protocol, or SSTP. Next, you have the Layer 2 Tunneling Protocol, or L2TP. And finally, you have the point-to-point tunneling protocol, or PPTP. Now, don't let the PPTP name, or point-to-point, worry you too much. It's a little confusing, but you can use that as a remote access mechanism as well, even though it says point-to-point in the name. Now, the order that I have these on the screen actually matters. IKEv2 is the most secure connection method, and PPTP is the least. They go in declining order of security. IKEv2 and VPN Reconnect is brand new in Windows 7 and only works with Windows 7 and Windows Server 2008 R2. This connection method supports IPv6 as well as VPN Reconnect, which we'll be discussing soon. It's also network address translation friendly. There used to be a day when VPNs were a real pain in the neck to administer because network address translation continually got in the way. With network address translation being in wide use on the internet, VPN connection methods really do need to support NAT traversal, which is something that IKEv2 does. Next, the SSTP connection method, as its name implied before, which is the Secure Socket Tunneling Protocol, tunnels traffic over a secure socket, or port 443. This makes SSTP very firewall friendly because almost every firewall allows outgoing 443 connections. However, SSTP cannot be used in a web proxy environment that requires authentication for the proxy because it just doesn't work. SSTP, or tunnel over port 443, is not compatible with these kinds of environments. SSTP works in any version of Windows, including and above Windows Vista SP1 and Windows Server 2008. Now, the Layer 2 tunneling protocol with IP security is more secure than PPTP, and it's also NAT friendly, supporting NAT traversal when the underlying clients are capable of supporting NAT traversal. L2TP supports either a pre-shared key or certificate-based authentication. So what this means is your L2TP VPN type does not require the implementation of a PKI, or public key infrastructure, which can be pretty complex to get up and running. Instead, you can use a less secure, notice I say less secure, pre-shared key mechanism where you actually physically share basically a password with everyone. This is a very common VPN type, and it works in Windows 2000 and later. PPTP is the least secure VPN type, and it does not support the use of certificate-based authentication, but it's arguably one of the most deployed VPN types because of its simplicity, and it also works in Windows 2000 and later, and there are ways to make it work in Windows NT as well. Now that we've talked about the different VPN connection options you have in Windows 7, let's talk about some of the different VPN authentication mechanisms that are available, depending on which connection mechanism you use. There are a number of password-based authentication options that are available, starting with, again, the most secure down to the least secure. EAP/PEAP is the Protected Extensible Authentication Protocol, and you'll see that it's a MS CHAP v2, and we'll talk about some of these things in a little while. Next, you have PEAP, or PEAP-TLS, which is Protective Extensible Authentication Protocol with Transport Layer Security. Next, you have the Microsoft Challenge Handshake Authentication Protocol version 2, followed by the Challenge Authentication Protocol, and at the end of the pack, we have the Password Authentication Protocol. Now, these are password-based authentication options. You can also set up a VPN connection that uses a smart card or a pre-installed certificate rather than a password, or in addition to a password. EAP or PEAP, the MS CHAP v2 version, is the most secure of the password-based authentication options and requires a computer certificate on the VPN server, but no client certificate is necessary. PEAP with Transport Layer Security requires a computer certificate on the VPN server, with clients authenticating using certificates as well. MS CHAP v2 is a simple password-based authentication protocol, whereas CHAP is something similar, but it's not supported under Windows Server 2008's remote access services. It is, however, enabled in Windows 7 clients in order to allow Windows 7 to connect to other CHAP-based VPN servers. It's used as a fallback when more secure options are not available. PAP, or Password Authentication Protocol, is the least secure, and it's not supported under Windows Server 2008's remote access services, nor is it enabled by default in Windows 7, although it can be enabled if it becomes necessary to connect to one of these relatively insecure VPN clients. Brand new in Windows 7 is a feature called VPN Reconnect. It's intended to allow for a more stable remote experience by mobile users. Often, mobile users are going to lose their network connections as they move to different networks. They may move between Wi-Fi hotspots. Maybe they go from the Barnes & Noble to the Borders bookstore across the way. In between, they're going to lose their Wi-Fi connection. Or the internet may just go down on their home from which they're working that day, and they're going to, again, lose their remote access connection to the system. VPN Reconnect will automatically reconnect the user to the VPN connection with no intervention. Normally, when a VPN connection is lost, that's it. The user has to manually reconnect and try to until the connection is established. In the case of VPN Reconnect, the network connectivity can be lost for as long as 8 hours, after which point the user has to manually reconnect to the VPN server. Global Mantic has established a Windows Server 2008 R2 based remote access server. Your job is to create a VPN connection from a client and explore the possible VPN configuration options. Once again, we are on a Global Mantic desktop machine. And as you can see, right now I'm not connected to the internet, but that's okay because I'm just doing this for demonstration purposes and my servers are all on the internal network. You have to go to the Network and Sharing Center and go to Set up a new connection or network to create a new VPN connection. So I'll click that option, and this is going to start a wizard that allows you to set up a number of different kind of connections. On the Choose a Connection option page, I'm going to choose to connect to a workplace, which will allow me to establish a VPN connection to a workplace, and click Next. Now I'm going to be asked how I want to do this. Do I want to use a modem or do I want to use my internet connection? Well, I want to use my internet connection. But right now I don't have one. So I'm being told, do you really want to do this because you don't have an internet connection? Well, I'm going to set up an internet connection later, so I'll choose that option and we'll move on. Now the address to which I'm going to connect is going to be that 100.100.10.10 address that we've been using. And I'm going to name this connection Global Mantic. Now, a couple of things to keep in mind at the bottom are I can choose to use a smart card for authentication, and I can allow other people to use this connection. By allowing other people to use this connection, basically, if this is a shared machine, other people will be able to connect to this VPN connection if they have the appropriate credentials to do so. Next, I need to provide a username and password for Global Mantic. When you choose Remember This Password, make sure you don't lose your laptop because it will log in without prompting you for a password. And the domain is GM in this case. And I'll click Create. Now you're probably wondering why I didn't get asked about a number of other options, like what kind of connection method I want to use and all that good stuff. Well, if I go to the Network Center down on the lower right-hand corner of the screen, you're going to see that there's a Global Mantic option that comes up under Dial-Up and VPN on the shortcut screen now. I'm going to right-click that option and choose Properties, and you're going to see that that opens up the Properties page for this particular VPN connection. On the Options page, I have a number of options, as you might guess, related to this establishing this VPN connection. Nothing really here is all that important, so I'm going to move on to the security option, which is really the most interesting of the tabs. You'll notice that the type of VPN is automatic. In other words, Windows 7 is going to choose the best kind of VPN, the most secure, based on everything that it can find on the other end. If, however, potentially you're having problems with one of the VPN types, you can force a VPN type simply by selecting it. And as you make changes to the VPN type, you'll notice that the options in the lower portion of the screen change. So when I choose the IKEv2 option, my authentication options change to ones that are supported by that particular type of VPN, including protected EAP, secured password, which is the MS-CHAP, or a smart card authentication mechanism. And if you look at all of the different options, you're going to see that they all have different options. SSTP also allows the same options as IKEv2, And on the properties page, you'll get some other information. And you can choose to allow particular protocols if you want, such as unencrypted password, PAP, CHAP, or CHAP v2, which we talked about before. Notice that when you use IKEv2, you're not allowed to choose those insecure authentication types. You can also choose to use machine certificates if you would like for authentication, but I'm going to leave it at EAP. Let's take a look at L2TP, and you can, again, you're allowed to choose the EAP-based authentication types, or you can choose one of the less secure authentication types. And when we get down to PPTP, again, you're allowed to choose something secure or insecure, or I shouldn't say insecure, but less secure, but all of the options change depending on which type of VPN you're connecting to. You can also choose how you want the client to handle a case in which the server does not ask for encryption. So no encryption allowed. The server will disconnect if it requires encryption. Optional encryption. Connect even if there's no encryption. Require it. Disconnect if the server declines the encryption request. Or maximum strength encryption. Again, you'll disconnect if the server declines that maximum strength encryption request. On the networking tab, you'll get information about what's going to be used over this VPN connection. So you can configure your IPv6 and your IPv4 connections just like you would if you were to have this machine local, except there's fewer options. Notice that you can only provide an IP address for these particular systems. You're not going to provide a mask or a bunch of other stuff that you would normally provide, or a gateway address. File and printer sharing for Microsoft Networks is turned on, as is the client for Microsoft Networks, which basically allows this remote computer to access the contents of the corporate network and browse and all that good stuff. And if you would like, you can allow other users to connect through this computer's internet connection for internet connection sharing, just as you can for other network adapter types with Windows 7. Now, when you go to the Change Adapter Settings page, notice I have a Global Mantics option now of a WAN mini port type. And it's IKEv2 because that's what I set it to just a few minutes ago. If I go back to the Properties page, well, that's because it's an automatic type. It wants to be IKEv2 if it's possible. That's what happened. Sorry about that. I thought I set it to IKEv2. But if you want, you can choose this to be your default connection, or if you blew it and you want to start over, you can delete this connection and start over. We started this lesson by discussing direct access, starting with features and server requirements, and then we moved on to how you can configure direct access at the client side. We then talked about understanding direct access connection types as well as client requirements. Next, we moved on to how you can enable VPN-based remote access and talked about various VPN authentication mechanisms and password-based authentication mechanisms. We finished with a discussion about Windows 7 VPN connections. I've listed a number of supporting resources, mostly having to do with direct access, on this page that I think will be very helpful in helping you get even more knowledge about the direct access capabilities of Windows 7 and Windows Server 2008 R2. Thank you for listening, and I look forward to seeing you in the next lesson.